The other part of this lesson is about the area of triangles, and we have done this already this year, but just a reminder, and we're going to need to use it in the next chapter when we talk about volume and surface area. So I thought I'd go through and just review. So the area of the triangle, just like with a parallelogram, is based on that you have a base length and an height or an altitude that is perpendicular. So, and again, this figure can be moved in any different direction, turned, whatever, not a big deal. Okay. So meaning I could have a triangle that looks like this. This would be my base. That's my height. Okay. I could have a triangle whose base, because if this is my height, then this would be my base. So that figure, that triangle can always be rotated. The formula for a triangle can be written in one of two ways, either with a 1/2, so the area is equal to 1/2 base times height, or the area is equal to the base times height divided by 2. I prefer this one, but I'm not going to force you into using one or the other. So here's an example. The height of a triangle is 7 more than its base. The area of the triangle is 60 inches squared. Find the height and the base. So I'm going to sketch a picture because I don't have one, and I'm going to label that I have. I always, doesn't matter what type you have, I always just kind of sketch a right triangle. I just think that they're the easiest ones to sketch. But again, that's your preference. This way I know where my height and my base is because they're right angles. So the height of my triangle is right here and the base is right here. So I have that the height of the triangle is 7 more than its base. So I'm going to call one of those values x, and then I'm going to write the other one in terms of x. So if I call the base x, then my height is 7 more than. So more than, that right there means addition. Okay, so 7 more than its base. So my height, instead of calling it h, I can call it x plus 7 because it's 7 more than the base. I'm always going to write the formula for my area of a triangle as the full formula. We've talked about this in the past where we don't want to just write one side or the other. If you forget to write down that a, you are going to put things in the wrong spot. So a is equal to the base times the height divided by 2. We have to remember that divided by 2 with a triangle. And if we look at it here, if we had a rectangle, the rectangle is base times height, and that triangle is half of that rectangle. That's where the divided by 2 comes from. So let's make sure we're putting things in the right spot. So the area is 60. So 60 is equal to the base, which we call x, and the height, which we call x plus 7. Okay, so, and we all divided that by 2. So now we can solve for x. So I'm going to multiply both sides by 2 just to get rid of that 2 in the denominator. And I end up with 120 is equal to x times x plus 7. We have to remember that that x is being multiplied by the entire quantity x plus 7. So what do we have to remember to do? We have to remember to distribute. So we end up with 120 is equal to x squared plus 7x. And now I have a squared, x squared, and I have an x. So here I have a quadratic. And we know how to deal with quadratics. We should be factoring them. So I'm going to get everything to one side because I want it to be in the form of ax squared plus bx plus c is equal to 0. I personally would rather solve these. So I paused my video, so I'm going to repeat. I don't know where I left off, but I would much rather solve these where my coefficient of x is the positive value. So I want a positive value here. So I'm going to take this 120 and move it to the other side. So I'm going to subtract that. So that 0 is equal to x squared plus 7x plus or minus 120. And now I can factor that quadratic. So pause the video here and work through that process. If you've forgotten how to do that, you need to go back and review that. We've done it a lot this year. So I've taken a moment and I've solved my quadratic, and you should have as well. And when you solved your quadratic, you should have gotten x is equal to 8 and x is equal to negative 15. So we should always double check both values. In this case, we know that it can't be the negative value because x is our base length right here. So if we put that in there, we would have a negative length, and we know that that can't be right. So we can't use that. Now, you can't just rule out the negative. You always have to kind of have that logical thought process, because sometimes when you plug in your negative, you end up getting a positive value. So we have to find the height and the base. So our base, because that was our x, is 8 inches. And our height, because we're adding 7 to it, would be 15 inches. So this right here is our x, okay? And then the h is the x plus the 7. So these are our answers. We didn't do an example here, but in these practice problems, just be aware that when you're working with triangles, you might have to use trig or special right triangles or Pythagorean theorem to help you find a missing value. So the same stuff that you used when you were working with parallelograms. If you have any questions about this video, reach out.